This unit is looking at linear momentum and asking the question, what is momentum? So to start off, I want to talk about linear momentum, and that's the quantity of, the quantity of the mass of an object multiplied by its velocity. So in and of itself, momentum isn't really it's not a thing we directly measure, but it's a thing we calculate, and it's similar to energy of it doesn't necessarily have meaning on its own, but it ends up being really useful to describe relationships, make predictions, etc. So that's why we want to kind of talk about it here. So in other words, we're going to say that P equals mv. So P is the variable that we use for momentum, is a lowercase p. And the units for momentum are what you'd expect just from looking at them, kilograms times meters per second. So that's the definition of momentum. It's just mass times velocity. So if an object's moving and it has mass, it has momentum. There's a couple places where this gets weird and kind of modern physics, but we're not going to worry about it in this class. But if you're curious, let me know and we can talk about it more. So momentum can be large if mass, velocity, or both are large. So something with a lot of momentum doesn't necessarily have to have a lot of mass if it has a lot of velocity. Something with a large momentum doesn't necessarily have to have a lot of velocity if it has a large mass. So it could be both, it could be one, it could be the other because of this expression here. Conversely, momentum can be small if mass, velocity, or both are small. So if you have a really, really, really big object, but it's traveling very slowly, its momentum can still be quite small. If you have a really, really small object that's moving really quickly, it can still have a quite small momentum. It's just kind of, when we look at it, is the bigger effect or the smaller effect more pronounced? So just do a couple quick examples here to do some calculations. Calculate the momentum of a 110 kilogram American football player running at 8 meters per second. Momentum is mass times velocity, so the momentum is equal to 110 kilograms times 8 meters per second, and that will equal 880 kilogram meters per second. So that's its momentum. Compare that to a hard-thrown football of 0.41 kilograms and a speed of 25. So P is equal to m times v. P is equal to 0.410 kilograms for, let me rewrite that so it's clean, times 25 meters per second. And that will equal, it's going to be roughly 10, I think. Yeah, it's going to be a bit over 10, but let's get the exact number. 10.25. And again, the units kilograms, meters per second. So that's the idea behind momentum. Pretty straightforward. It's literally just multiply mass times velocity.